Hello, friends. We are back again to talk about angle relationships. We're going to go through a handful of angle relationships and theorems about angle relationships, and then we'll use those as we begin constructing proofs about different angle relationships. So first, I want to review what the definition of congruent angles is. This is a reason that we'll use as we want to convert back and forth between congruent symbols and equal signs. So we can go back and forth between those two notations by using the definition of congruent angles. Angles are congruent if and only if their measures are equal. So when you are using congruence symbols, you do not use the M that is for measure, and that part is required when you have equal signs. Okay? This is really important as we're leading into our first theorem, or postulate really, about angles, the angle addition postulate. So we looked at the segment addition already, so this is just extending that theory and to angles. So we're using the M's and the addition symbol to talk about how these two smaller angles create one larger angle. So we have, because D is in the interior of angle ABC, we have this angle here, right? Angle ABD, that when we add that to angle DBC, this one right here, adding those two pieces together, we get the large angle, and I can kind of highlight that here on the outside, the large angle there. Okay, so anytime that you have a picture like this, you can write an addition problem with using M for measure and a plus signs and equal signs to break that large angle down into two smaller angles. So we can now talk about theorems about angle relationships. So supplement theorem says that if two angles form a linear pair, so recall a linear pair means that they are adjacent, okay, then and they form a line, then we know that they have to be supplementary. The only way that those two adjacent angles are going to form a line is if they add up to 180 degrees. So verbiage and terminology here is very important. We got to pay close attention to detail. So if we are given that two angles form a linear pair, then by using the supplement theorem, we can say that they are supplementary. I want to contrast that to the definition of supplementary, okay? So a linear pair means that they are supplementary. That angle goes, or that arrow here goes one directional, okay? So if they're a linear pair, then they're supplementary. You can make that conclusion. Then once you have stated that some angles are supplementary, you can write an equation that says that their measures add up to 180 using the definition of supplementary. Okay, so those are two different reasons that you will use in your proofs for justifications, okay? So supplements theorem, you're starting with a linear pair and you want to say that they're supplementary. But if you have the term supplementary and you want to write an equation, then you use definition of supplementary. So we can do that same idea then with complementary. So if two angles form a right angle, okay, then they are complementary. So since they form a right angle, they're complementary, which we contrast with the definition of complementary, which says that their sums are 90. Okay, so if we know two angles make a right angle, we can say they're complementary with a complements theorem. Then we can write an equation that they add up to 90 using the definition of complementary. Okay. A couple other ideas that we had in chapter 1 that we're just going to formally state here in chapter 2, give them a name. So this is the vertical angles theorem. Vertical angles are congruent. So if you are looking at a picture and you see that you have vertical angles in a diagram, then you could, in a proof, say that angle 1 is congruent to angle 2 because of the vertical angles theorem. Same thing with right angles. If you're looking at a picture or a diagram and you see that you have right angles marked in your picture, you can make a conclusion from that. You can say, well, those have to be congruent to one another because they are right angles, and that is the right angles theorem. Now we're contrasting that to the definition of a right angle, which is that it is 90 degrees. Okay, so recognizing the difference between those terms. And those are the major theorems and definitions that we'll be using as we begin looking at section 2.8.